So let's look at the procedure to draw root locus. There are 7 steps basically that we need to draw a root locus of any characteristic equation associated with the transfer function. So first we're going to go ahead and write the characteristic equation in the form of 1 plus fs, where remember fs is what? K plus k times gs. So we arrange the equation such that k appears as a multiple of a polynomial. We're calling this polynomial ps, js, whatever you want to call it. So the basic idea is, again, find locus of all roots of the characteristic equation as k changes from 0 to infinity. We write 1 plus kps equals 0 in terms of 1 plus k product of all the zeros and divided by product of all the poles. So a polynomial in fractional form, transfer function or loop gain rather in fractional form. So the first step is that you locate zeros and poles of PS, this is PS remember, on the S-plane and mark them with 0, and poles mark with X. So let me show you an example real quick. You have to do a project on this as well, so I'm going to discuss project later, but let me just go ahead and show you what I mean. So here is it. So in this case, PS is this: s plus 1 over s plus 2, s plus 4 square. So I have a 0 at s is equal to -1, which is right here, 0 at s is equal to -1, and then I have one pole at s is equal to 0. This is the pole at s is equal to 0. One pole at s is equal to -2. This is the pole at s is equal to -2, and then I have basically two poles at s is equal to -4. So I have double pole over here. It's hard to see, but there's a double pole over here. So this is the first step, as to locate those zeros and poles of PS and mark them on S-plane. Let's go back. Okay, so 1 plus fs is equal to 0 can also be written as, this equation can also be written as product of all the poles plus k product of all the zeros is equal to 0. So you just simplify this equation. Product of all the poles plus k product of all the zeros is equal to 0. So when k is equal to 0, what do you have? You have product of all the poles equals 0. That means that when k is equal to 0, you are standing on poles, because of course when you calculate roots of this, when k is equal to 0, that's going to give you poles. So basically at k is equal to 0, you are standing on poles of the loop gain, poles of 1 plus kgs, and that's where your root locus starts. Basically different portions or different what we call different root loci start at poles. So if I go back here, here, root loci start at poles. So all these different root loci that you see with different colors, they start at each pole. So one is starting here, this line, one is starting here, this line, one is starting here. Now remember, there are two poles over here. So one is starting here, which is going this way, and then the other pole that is here is going this way. So it is starting at each pole. And then when you make k infinity, then what you're going to get? You are going to get, when k tends to infinity, then this product, when you put k is equal to infinity, this product will become very large compared to this product over here. When k is infinity or close to infinity, of course not infinity, but close to infinity, this product is going to become extremely large as compared to this product, such that we can ignore this thing. So what's going to happen? Sum of, or product of, all the zeros equals to 0 when k tends to infinity. So that means, and of course the roots of this is going to be what? Zeros of 1 plus kgs. So that means when k tends to infinity, it is basically the root locus, or the different root locus or root loci are heading towards zeros. That means they start at poles of 1 plus kgs or 1 plus kps, whatever you want to call it, and they end at zeros. So if I go over here, starting at one of the poles heading towards 0, starting at one of the poles, and the 0 for this is sitting at infinity. There is no finite 0 over here. Again, starting from this and again going towards infinity where another 0 is sitting. We're going to discuss this soon. And then again starting from this, since there are two poles over here, starting from this and heading towards infinity again where there's a 0 sitting over there. This thing we're going to discuss pretty soon. So again, your step number 1 is find all the zeros and poles of PS and put them on the S plane. That's step number 1.